Hi everyone, I'm Maggie Cheng. I'm the General Chair of SmartGIFT 2020. It is my honor to welcome you to the 5th EAI International Conference on Smart Grid and Innovative Frontiers in Telecommunications. The theme of SmartGIFT 2020 is on smart grid data sensing, data processing, data communications, as well as security and privacy. After 4 successful conferences in other countries, the committee decided to hold the conference in the beautiful city of Chicago in the United States of America. However, due to the pandemic, we had to change the plan and hold the conference virtually. This year, many authors faced financial and physical constraints that limited their participation in international conferences. Despite being in such a difficult time, we received 32 submissions. Each paper received at least 3 peer reviews, and 16 best papers were selected. Behind the success of every conference is the hard work of the Technical Program Committee. The 3 program chairs are my colleague Yuan Hong from IIT, Peng Yu and Huibing Jia from China. From selecting committee members to coordinating reviews, they worked tirelessly to ensure our papers received adequate reviews. I'm lucky to work with them through this journey. We also feel very fortunate to have EAI Conference Manager Natasha Onofre to work with us. Without her providing resources and support, we can't possibly keep the conference on schedule for all major milestones. We have put together a compact one-day program for you. The program includes 1 keynote and 3 technical sessions covering a broad range of topics. These carefully selected papers integrate the recent advances in networking, machine learning, security and privacy with cutting-edge research in smart grid. Each presentation will be followed by a brief discussion on Slack. I welcome you all to join the Q&A session on Slack and make it a productive day.
Ladies and gentlemen, welcome to the 5th EAI International Conference on Smart Grid and Innovative Frontiers in Telecommunications, EAI SmartGIFT 2020. My name is Natasha Onofre and I am the conference manager of this year's edition. Unfortunately, due to the pandemic, I'm not able to meet all of you in person, so I'm using this opportunity to address the organizing committee, the authors, and our online audience on behalf of the European Alliance for Innovation. First of all, I would like to thank you all for being part of this conference and for your involvement with the EAI. Above all, I would like to express my gratitude to the General Chair, Maggie, Cheng, and the Program Chairs, Yuan Hong, Peng Yu, and Huibin Jia for their excellent work in organizing a successful conference in these difficult times. Also, I'm very glad to be able to announce that the 6th edition of SmartGIFT will take place next August in Auckland, New Zealand. I invite all of you to participate in our 2021 edition by submitting your papers, by organizing a workshop, or by joining the Technical Program Committee. In fact, at EAI we're constantly striving to promote innovative research in the field of information and communication technologies. So if you have an idea for a conference, a workshop, or you would like to collaborate with us in any other way, please contact me at the email address below. Thank you all for your attention and enjoy the conference.
Hi everyone, my name is Outage. I'm the community manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello everyone. I'm honored to have this opportunity to give a presentation here. My report is about a new similarity measurement method for the power load curves analysis. I will introduce our work from the following 4 parts: introduction, methods, experiments, and conclusion. And the first part is introduction. A large number of valuable information contained in the power load curves has produced a great interest in power load analysis in recent years. The power load curves are always adopted to describe the variation of power load with time, and reflect the characteristics and the rules of users' electricity consumption. Generally, similarity measurement of the power load curves is popular to be used in load analysis. As the basic of load forecasting and load pattern recognition, similarity measurement had various applications, such as optimize source load storage coordination, analysis users' behavior, forecast energy consumption, and detect non-technical loss for metered customers in power utility. Therefore, it is of great significance to increase the quality of similarity measurement. There are a lot of methods have been designed and proposed to increase the quality of similarity measurement. Although those methods have achieved some results in load analysis, they should not applicable to varying degrees. Some of them have complex calculation procedure. Some of them can't meet the requirement of power system analysis. Before digging into the methods, I want to take a brief introduction of the power load curves similarity. For the power load curves, there are 2 factors influence the degree of similarity. The one factor is numerical similarity, which is reflected by the distance of 2 power load curves on the same sampling instant. The other factor, shape similarity, is the consistency degree of the dynamic changes of 2 load curves during the whole sampling time. As shown in Figure 1, the distance between point A and point B reflects the power load curve's numerical similarity, and the shape similarity can be measured by comparing the shapes and the variation trend of each curve. Among all the similarity measurement methods, Euclidean distance and dynamic time warping distance are used commonly. Let's begin with Euclidean distance. Suppose there are 2 load curves with lengths n, x and y. To compare the similarity between x and y, Minkowski distance is used as this, where r is the distance coefficient of Minkowski distance. Different values of r result in different similarity measurement methods. Euclidean distance is a special Minkowski distance when r equals 2. So the Euclidean distance between x and y is as this. The definition of Euclidean distance shows that the process of Euclidean distance works is a strictly point-to-point calculation and simple to implement. But on account of using the square of the difference between xi and yi, Euclidean distance ignores the sign of xi minus yi. Therefore, Euclidean distance is not sensitive to the fluctuation of the load curves. which results in the lack of shape measurement capability. Figure 2 shows 3 daily power load curves A, B, and C of different users on the same date, where each curve has 24 sampling points, and the sampling interval is an hour. Calculating the Euclidean distance between A and B, A and C. The results are shown here. The calculations results indicate that the load curve A is more similar with load curve B, but load curve A is more similar with load curve C when comparing the shape and the variation trend of 3 load curves as shown in Figure 2. The other classic similarity measurement method is dynamic time warping distance, DTW, based on the thinking of dynamic programming. This method searches for a shortest path through time stretching or warping, which makes the distance between 2 load curves is minimum. The definition of DTW is this: 2 points connected by a black line in Figure 3 are the similarities of the load curves A and B. When several points correspond to 1 point, the time warping will occur. The sum of the distances of all the similarities is DTW distance. In spite of DTW, could recognize the load curve's shape features to some extent from Figure 3. It's not a good choice for the power system load analysis, because the timeline of the load curves is not fully aligned. DTW neglected the numerical distribution on the timeline. This measure may cause overwarping sometimes, and not reflect the real change of the power load. In addition, DTW also have the shortcoming of high complexity. Generally, the similarity measurement method should be designed with specific problems. In the power system load analysis, both numerical similarity and shape similarity of the power load curves need to be concerned by similarity measurement method. Even though Euclidean distance and DTW are competitive for many fields, they have some shortcomings as a method to measure the similarity of the power load curves. Each of them could not consider numerical and shape similarity at the same time, and the calculation of DTW has no advantage in speed. Focus on these issues. A modified Euclidean distance for the power load curves is proposed as the new similarity measurement method. The MED between the load curves X and Y is defined as this, where delta is a shape correction factor defined as this. The definition of MED shows that Euclidean distance can be made having shape measurement capability by introducing a correction factor and not compromising time warping. The correction factor delta is a standard deviation of xi minus yi, which represents the fluctuation degree of xi minus yi. The more similar the two load curves are, the smaller the delta is. Delta offsets the shortcoming of Euclidean distance, that it couldn't consider the sign of the value of xi minus yi. The algorithm of MED is shown as follows. It can be easily implemented. Now we move to the part of experiment. to verify the feasibility and effectiveness of the proposed method. Three described methods, ED, DTW, and MED, are applied to the load curves with similarity measurement and clustering. The dataset we used is from OpenEI, commercial and residential hourly load profiles for all TM3 locations in the United States. The first experiment is similarity measurement. We selected 4 load curves from the above dataset, as shown in Figure 4. The x-coordinate of the curves is the time point, and the y-coordinate is the load value. The calculating results are shown in Table 1, and the calculating time is shown in Table 2. As shown in Table 1, the calculating results show that the calculation accuracy of MED is the same as existing methods ED and DTW. Among all adopted methods, curve line 3 and line 4 are the closest, which conforms to the result of manual interpretation. And the second highest similarity is line 1 and line 4. For all methods, line 3 and line 4 owns the farthest distance. In terms of calculating time, as shown in Table 2, the calculating time of MED is little more than ED, but less than DTW. The second experiment is clustering analysis. In this part, we use the k-means clustering method to compare the effect of different distance measurement methods. The value k is confirmed by Davis Body Index. dBi is also used for evaluating the quality of clustering. 640 daily load curves of 16 kind commercial and residential customers of 4 different cities are chosen from adopted dataset. As shown in Figure 5, K is better chosen file to realize clustering. The clustering results of 3 similarity measurement methods are shown in Figure 6 to Figure 8, respectively, where A is the clustering result and B is the calculated clustering center. This figure is the clustering result for ED. And this figure is the clustering result for DTW. And this figure is the clustering result for MED. As shown in Figure 6 to Figure 8, all 3 methods realize clustering efficiently. But the clustering results are a little bit different. The clustering results are shown in Table 3. We can see that MED decreases the dBi index compared with ED and DTW, which results in a more accurate clustering result. Besides, the clustering time of MED is the shortest, while the calculating time of DTW is much longer. The conclusion of our work is shown as followed. We designed and proposed a modified similarity measurement method based on conventional Euclidean distance, focused on the issues for existing similarity measurement methods. Proposed method reflected the change of curve shape without complex calculation. Besides, the advantage of proposed are proved by similarity calculation and clustering analysis in experiment validation. Compared with Euclidean distance and dynamic time warping distance, The proposed method increases the clustering effect without increasing the calculating burden significantly. In future, the proposed algorithm will be implied into other clustering algorithms, and the parameter that reflects the change in shape will be improved to increase the clustering effect further. That's all for my presentation. Thank you.
Hello everyone, my name is Liu Zhengyuan. My primary affiliation is Beijing University of Post and Telecommunications. I'm going to explain the paper Resource Prediction and Allocation Method for 5G C-RAN based on Power Internet of Things. Firstly, I will introduce the background, and I divide this part into three parts. First part is reducing electricity prices. In 2020, the working report of the Chinese government proposed to reduce the industrial and commercial electricity price by 5% until the end of the year. And the second is promote industrial recovery. Investment in the construction of the Power Internet of Things can effectively promote the recovery of the upstream and downstream of the industrial chain and play an important role of power grid investment. And the third part is smarter. The system information is effectively used to realize the intelligent data driving of the system, which greatly improves the utilization efficiency of resources. Secondly, I will introduce the research questions of this paper. They are traffic prediction problem and resources allocation problem. The traffic prediction problem is the access site traffic of the base station is greatly affected by the temporal and spatial changes, and allocating resources with the maximal flow will cause a great waste of resources. Therefore, how to accurately predict the access site traffic is one of the focuses of our paper. And resource allocation problem is BBU computing resources are virtualized into cloud by virtualization technology, and all RRHs are connected to this virtual cloud on the premise of accurate prediction of accurate sites, access site traffic. How to reasonably allocate network resources is the focus of our research. And I combined the two questions in this paper. The network resources are allocated according to the prediction results. Thirdly, I will share the data collection and processing part. Please look at the equation 1. It can be used to smoothing the data. MA is the average value. TI is the traffic data collected. J is the starting position of the window. W is the window width. The window width can be manually set according to the original data and the smoothing effect. The window width used in this paper is 10. The comparison of data smoothing before and after is shown in the figure. Figure A shows the original network traffic data, and Figure B shows the network traffic data after data smoothing. Firstly, I will introduce the network traffic prediction based on STN. The loss function is as equation 2. The STN layer time step of the STN-based traffic prediction mode is set to 40, and then the STN layer is connected through the for connection layer NLP. Addon is used as the optimizer, and MAE average absolute error is used as the loss function. The network traffic prediction mode based on STN is well trained, as shown in Figure A. When the mode is applied to the network traffic prediction of access sites, it can predict the trend of network traffic better. But at the same time, the ability to predict the small random fluctuation of network traffic is poor, as shown in Figure B. Then I will introduce the network resource allocation algorithm based on genetic algorithm. This part is mainly includes the objective function and the cost function. Equation 3 is the sum of system energy consumption. The optimization strategy in this paper is to minimize this value while maintaining network QoS. Equation 4 is the calculation formula of the total energy consumed by BBU and the calculated energy consumption of each BBU is superimposed. Equation 5 is the energy consumption of task migration between BBUs, which is directly proportional to the amount of transferred tasks. The follow chart of algorithm is as follows, and I will mainly introduce the three parts of genetic algorithm. Selection by calculating the energy consumption of baseband processing and task migration. The total energy consumption required for each transaction is the fitness of the mode can be obtained. The higher the total energy consumption, the lower the environment adaptability. Crossing is the exchange of genes between two trans in which a more adaptable transition may be obtained and the crossed transition will be added to the offspring populations. Mutation after transition crossover, there is a certain probability that a gene mutation will occur. At this time, two numbers are randomly generated to determine the specific location of the mutation and the value of the mutation. The simulation result is as follows. Figure A is the genetic algorithm fitness iteration graph. The genetic algorithm can gradually converge in the process of iteration. Figure B is BBU active number comparison diagram. The network resource allocation algorithm based on genetic algorithm has a little more BBU's activity in the same network environment as existing algorithm. Figure C is the comparison diagram of UE migration times. Compared with existing algorithms, genetic algorithm has better performance in task migration times. Figure D is a comparison of total power consumption of system. Genetic algorithm has better performance than existing algorithms in total energy consumption of the system. My share is ending. Thank you for watching.
Hello, all real teachers. I'm Wang Haoyu. My essay topic is the design and implementation of D2D communication-based 5G code real access networks Q outage compensation model. Next, I will describe the overall process of the paper from the following context. The part 1 is subject background and overview. The part 2 is optimization model. Part 3 is research process. Part 4 is simulation results and analyze. Part 5 is summary and outlook. Now, let's look at part 1. The part 1 is subject background and overview. I extracted 2 key information points from the subject, namely 5G serial network and D2D technology. The left picture is the architecture diagram of 5G serial network, which is based on centralized processing. Its general goal is to solve the various challenges that the rapid development of mobile internet brings to operators in the future. It integrates the baseband processing unit of the traditional base station into a BBU Pro, connected to the remote radio unit RRU through an optical figure link, and then RRU sets the signal to each terminal devices. Due to the rapid increase in business volume in the future 5G network, the network load is large, and the network features are extremely easy to corner. It is particularly important to perform fast network compression after network features. However, due to the large number of RRUs and the small coverage of a single unit, D2D technology is adopted. Network compensation is a good idea. The figure on the right is a flowchart of D2D connection in a 5G serial network. The source terminal and the destination terminal first set their own state requests to the BBU Pro through the RRU, and the BBU Pro performs overall scheduling. Finally, the resource terminal and the distance terminal completes the bring-in connection. The content to be introduced below all corners in the BBU Pro. The goal of this article is to build a suitable optimization model and use the operate algorithm to minimize the total energy consumption of the system during the D2D connection process. Next, I will introduce the experiment of the optimization model. First of all, the left picture is a D2D diagram under the interrupt network. One of the RRUs causes the device network in layer A to be interrupted due to the future. At the same time, other devices in adjacent layer use D2D to compensate for the interruption. To expand the compensation range, I introduced a D2D single layer model, just like the D2D compensation pair of layer A and layer B. For the single layer model, its channel capacity and link success rate are determined by the following formulas. Here, only the case where the two-hop link is interrupted at the same time causes the internation to fail. So, the particule of the success rate is greater than the threshold. The following describes enter D2D connection process and the optimization goals of each process. I introduce the specific process of the richer in stage. In the D2D connection, I introduced the social network model. The figure on the right is its conceptual diagram. In the social layer, a user connected by a social link indicates that there is a social relationship between the two users. In the physical layer, a link between two terminals indicates a communication relationship, and a user and a terminal connected by a dashed line across the two layers indicates the extent of the communication relationship. There is a one-to-one connection between users in the SOAP layer and the terminals in the physical layer. The more frequently two-user communication in the SOAP layer, the more likely their devices will communicate in the physical layer. For the routing process, the social layer succession is ended before the conventional selection plan, and the centrality, similarity, and trust are unfaded into an ununited faction. The united faction is used to first skin out the terminal devices that meet a central deal of intimacy, that is, set threshold value, directly remove devices with low intimacy. So attributes are collected and provided by the BBU Pro. The figure on the right is the route selection process. The equipment to be compensated indicates a request to the BBU through the RRU. The Cloud BBU Pro performs analysis and modeling calculations and filters, and then selected suitable real terminals in the selected return set according to the original plan. For the resource allocation process, the dating meeting model is based on social attributes. That is, the degree of association is determined by the distribution of the range of encounter between two terminals, and the probability of successful communication between them is determined. Probability communication occurs cannot resort to devices with a high success rate. The purpose of model optimization is to find the phenomenology of device allocation. In practice, the source terminal performs allocates canals of canal conditions to the terminal with higher priority. A wide width of resource. Calculate the communication success rate according to the length of time the user of two devices meet in SOAP layer, and then sort the communication success rate to determine the allocation probability, and allocate the divided canals to each D2D pair according to the probability to reduce canal resource waste. The last part is the simulation results and analysis. First, the simulation process is introduced. It is divided into two stages according to different processes. For the routing stage, first append the attributes of a set sort network, and then pass the simulation determines the source code of unity faction, and use the appreciate source code for real routing. For the source allocation process, first append the seat in corner time. Determine the communication success rate according to the internal time, and use the priority discharged by the success rate mark source allocation. These are three simulation diagrams of the routing process. Figure 1 is the determination of the unity faction source code. It can be seen that as the source code continues to increase, the device discovery rate continues to rise, reaching a peak about 0.7, and then repeatedly increasing is 0. Because as the source code value increases, the intimacy between the real device and the source device continues to increase, and the similarity between the two devices is getting higher and higher. But there are always differences between different devices. If the source code is too large, there will be no matching device, resulting in lacking its displacement feature. So we set the source code to 0.7, and the two pictures at the left are the real selection model based on source attributes and the OOE routing model, as well as the performance comparison of the random routing model. The independent variables are the path loss indicator and the distance from the source terminal to the destination terminal. By comparison, we can say that the OOE model has a significant reduction in energy consumption for random selection, and the model processed in the per future reduce energy consumption. Then, there is the kernel allocation process. For resource allocation, I simplified the model and adopted the D2D direct connection model. 3 pairs of D2D devices and 3 model devices were set in the scheme, and the kernel was originally decomposed into 6 points. First, configure the simulation environment. In the entry environment, the recovery kernel lists of original users and D2D users and 427 kbit per second and 438 kilobit per second, respectively. The kernels follow the relaying distribution, and the kernel date is extracted at a central moment as shown in the right figure. Scheme 1 uses random kernel allocation, and Scheme 2 uses kernel allocation based on the encoder model. In the scale, set the connection success rate of 3 pairs of D2D devices to 0.3, 0.5, and 0.7, and their priorities are 0.6, 1, and 1.4, respectively. The picture on the right shows the kernel allocation of 2 schemes. In the second scheme, the success rate of 3 pairs of D2D devices is reset, and the allocation summation is shown in the future. Then, the total information transmission rate in 2 scales. We can say that the resource allocation scale based on the encoder model is better than random allocation scale in both scenarios, and the transmission rate increase in scenarios 2 is even greater. This is because the communication success rate of D2D pairs in Scale 2 is quite different. Using this solution can prevent devices with a low communication success rate from wasting better resource and thus improve the overall rate. The last part is summary and outlook. D2D technology can better realize the queue interruption conception take in the 5G serial network with a small coverage of single RRH. Introducing the concept of SOAR networks into the D2D routing process can figure out more qualified D2D pairs and reduce system energy consumption. The introduction of the Internet model in the D2D channel resource allocation stage can allocate a channel with a faster transmission rate to a link with a higher communication success rate, improve in resource utilization. The above is all the content of my graduation project. Please correct me and comment. Thank you all teachers.
Thank you, Professor. Greeting everyone. I'm honored to represent my team to give a presentation about our recent work, and the title is same with this presentation: Service Capability Optimization Algorithm for Power Communication Network Service Providers in Competitive Game Environments. This work is done by Li Zhi, Duan Kai, Xu Tingting, Guo Shaoyong, and Shou. As the slide shows, my presentation is divided into 6 parts. First of all, I will introduce the background of our work. Then the problem description will be given. In the third part, we design a competitive game model. In the fourth part, I will present the details of our algorithm. In the fifth part, the results of the performance analysis will be presented. And the last part is our conclusion. First, let's start the introduction. The first part is the introduction. In the field of electric power, with the rapid development of smart grid business, the demand of power communication network is gradually increasing. The network infrastructure built by power companies can't miss the development needs of smart grid business. According to the business needs, power companies can adopt self-built power communication network to transmit power business, or rent third-party communication network resources to meet the needs of power communication business. The technical contribution of this paper can be summarized as follows. This paper first constructs a game model of power communication network service provider in network as a service environment. We also analyze how to release the resource allocation algorithm of power companies' revenue maximization under incomplete information. Finally, the rationality of the model is verified by simulation experiments. The second part is problem description. The Power Communication Network Resource Management Agriculture is shown in the figure on the left. It includes self-built power communication network service providers (SSP), third-party power communication network service providers (TSP), power communication network resource allocation center, and demand sides of power communication network. DS can make resource requests to the Power Communication Network Resource Allocation Center. In this paper, USI key and UIJ key are used to represent the effects of SSPI TSPJ. We use pi SI key and pi TJ key to represent the profits of SSPI and TSPJ. This paper uses the following two formulas to calculate the utility and the profit of service provider respectively. Next, we will introduce the proposed competitive game model. Based on the expectation value of KS1 and KT1, the expected value of service capability and the revenue function of service provider are shown in the following formula respectively. To maximize the profit, SSPI and TSPJ improve the service quality by adjusting the service cost coefficients so as to obtain the maximal market share and maximize the profit. Therefore, the objective function of the two is shown as follows. Considering that the players need to reach the final Nash equilibrium through multiple games, this paper uses Jacobi iterative formula to calculate the service capacity. By analyzing the above formula, the Jacobi iteration formula of service capability is obtained as follows. Next, I will briefly introduce the algorithm designed in this paper. The algorithm flow chart is shown in the right figure. The name of algorithm is Optimization Algorithm of Service Providers' Service Capability in Competitive Game Environment. The specific steps is shown as the left in the picture. Step 1. Initialize the service capabilities of self-built network service providers and third-party network service providers. Step 2. For each service provider, the Jacobi iterative formula is used to solve the optimal service capability of the service provider. Step 3. Calculate the expected value of service capability of each service provider. Step 4. Judge the results of a competition game until the equilibrium state is obtained. Step 5. The Resource Allocation Center allocates resources based on the service capability of each service provider. The algorithm flowchart is shown in the right figure. Next, we show the performance analysis of experiments. In order to verify the comparison of the results of the optimization of the power communication network service providers' service ability, 3 kinds of competition game models are simulated by using MATLAB. Because the limitation of competition environment in this paper is more in line with the actual situation, and that is, each service provider cannot know each other's service cost coefficient. In the experiment, this environment is compared with the unrestricted environment. In this paper, the incomplete information game is called incomplete competition. The picture on this page shows some simulation results. In this paper, the competition between SSP1 and TSP1 is used to simulate the competition between SSP and TSP. The experimental results are shown in the right figure. It can be seen from the figure that the convergence of TSP1 and TSP2, SSP1 and TSP1 are the same as those in the previous page. Therefore, the competition between TSP and between SSP and TSP has achieved Nash equilibrium, which is more in line with the actual production environment. The competition between SSP1 and SSP2 is used to simulate the competition between SSP. The experimental results are as shown. It can be seen from the figure that when the competition starts and incomplete and complete information, both of them don't know the results input of the other party, so the service capacity is not fixed. However, with the increase of the number of iterations, the service capabilities of the two gradually converge, and the service capability under complete information is lower than that under incomplete information. It shows that SSP1 and SSP2 can reach equilibrium in competition only when they invest more resources and incomplete information. The picture on this page shows some simulation results. Based on the analysis of the above simulation data, it can be seen that the service capability optimization algorithm of power communication network service providers proposed in this paper can be convergent in a variety of applications, and it is more in line with the real environment than the competitive game and complete information. So, it has more practical significance for power companies to choose power communication network service providers. The picture on this page shows some simulation results. We can compare the algorithm from these pictures. The last part is a conclusion. With the increasing demand of power communication network, the network infrastructure built by power companies cannot meet the development needs of a smart grid business. So, this paper proposed an architecture of power communication network resource management, and analyzes the resource allocation algorithm of how to maximize the power company's revenue and incomplete information. The rationality of the model is analyzed by simulation experiment. The simulation results show that the research results in this paper have more practical significance for power companies to choose power communication network service provider. Although the algorithm in the paper is more suitable for the real environment, it only verifies that the model has a Nash equilibrium and does not conduct in-depth analysis of resource utilization. That's all. Thank you.
Hello everyone. Today I will introduce you a paper which is called Multi-Domain Cooperative Service Fault Diagnosis Algorithm on the Network Slicing with Software-Defined Networks. My presentation includes 5 parts. First, introduction. When network resources failure, how to quickly and accurately locate the fault has become a key issue that network operators urgently need to solve. When a virtual network service failure, each domain only knows its own internal failure information. When faults can't be located within a domain, the problem of how multiple domains can collaborate to locate faults has not been well resolved. To solve this problem, this paper proposes a multi-domain cooperative service fault diagnosis algorithm on the network slicing with SDN. The algorithm improves the performance of the fault diagnosis algorithm through the cooperation of multiple management domains. Secondly, system model. The network slicing environment includes the underlying network topology and the virtual network topology. The resource allocation relationship between the virtual and the underlying network can be shown. When the virtual network covers a large area, Multiple domains need to cooperate with each other to meet the resource requirements of the virtual network. The service model of multi-domain collaboration is shown in this figure 1. It can be seen in this figure. It contains 3 managed domains, 1, 2, 3. The virtual network uses the network resources of these 3 management domains to construct a virtual network. When a virtual resource on a virtual network fails, the cooperation of 3 management domains is required to quickly locate the root cause of the failure. In order to quickly locate faults, a fault propagation model is constructed based on Bayes' zero, so as to correlate the observed symptoms with Arctic network environment. The fault propagation model is shown in Figure 2, including symptom top nodes and fault lower nodes, and a direct line from fault to symptom. Third, algorithm. The algorithm proposed in this paper includes the following 3 processes. First, symptom collection and fault decomposition. Each virtual network service provider reports symptom and fault information to the fault management center. The fault center performs fault decomposition based on the collected symptoms and the network topology. Then, the center provides management sends the fault information to the corresponding management domain. Secondly, building Bayes model. Each management domain uses detection technology to obtain the network performance of each fault node and feeds the results back to the fault management center. For links between domains, related domains need to send data packets to each other to obtain the packet loss rate of the link. Thirdly, fault site location. To select the most suitable fault site from the set of suspected faults to realize fault location. It adopts 2 processes. First, constructing a set of suspected faults. Second, locating faults based on Bayes' formula. We need to fault decomposition work, taking into account that each management domain can detect the failure of its own internal network resources. This paper divides paths to the resource of paths in the management domain and inter-domain link. When we fault set locate, we need to do two processes. First, when constructing a set of suspected failures, construct a set of suspected failures based on the number of simultaneous failures. Second, we need use Bayes' formula, this formula, to locate the fault. This formula can calculate the explanatory of the failure set. The fault set with the largest probability as the most likely failure set. Fourth, simulation results. In order to simulate the network topology in the network slicing environment, this article uses the GTITM tool to generate the underlying network and virtual network topology to simulate the network slicing environment. In order to analyze the performance of the algorithm in this paper, is compared with the non-cooperative service fault diagnosis algorithm. First, the comparison of accuracy rate can be seen in this figure. It can be seen from the figure that the size of the network has a small effect on the accuracy of the fault diagnosis of the two algorithms, indicating that the diagnosis performance of the two algorithms has little relationship with the network topology. From the comparison of the accuracy of the two algorithms, the accuracy of this algorithm is higher. The comparison of false alarm rate can be seen in this figure. It can be seen from the figure that the false alarm rate performance of two algorithms has little to do with the network scale. The false alarm rate of the algorithm in this paper is lower than that of the traditional algorithms. Lastly, the comparison of the time can be seen in this figure. In this figure, we can see as the network scale increases, the diagnosis time of the two algorithms is increasing fast. This is because as the network scale increases, the fault propagation model increases, and the size of the suspected faults also increases fast, which requires more time for fault diagnosis. Lastly, conclusion and future work. In terms of the conclusion, when network requests are composed of multiple management domains, the accuracy of services fault diagnosis across multiple domains is low. To solve this problem, this paper proposes a multiple-domain cooperative service fault diagnosis algorithm on the 5G network with SDN. These algorithms can solve these problems, but in the future, we need to improve this performance. In the future, we have some new idea. Now I show you some idea. With the increase of network scale and the development of artificial intelligence technology, how to further realize autonomous large-scale fault diagnosis is an important and feasible research topic. In the next step, based on the research results of these articles, we will explore a large-scale network fault autonomous diagnosis system based on artificial intelligence. Everyone, this concludes my presentation. Thank you very much. Hello everyone. Today I will introduce a paper which is called Fault Diagnosis Algorithm based on service characteristics on the software-defined network slicing. The content includes 5 parts. First, introduction. In order to ensure the stable and reliable operation of 5G services, fast and accurate fault location technology has become an important task for network managers. Because software-defined network slicing technology realizes dynamic migration and undemanded allocation of resources, the relationship between faults and symptoms is more complicated, resulting in a decrease in the accuracy of the fault diagnosis model, thereby affecting the performance of fault diagnosis. In order to solve the problem of low performance of fault diagnosis algorithms caused by network dynamics, this paper proposes a fault diagnosis algorithm based on service characteristics on the software-defined network slicing. Based on the relationship between network resources and services, the algorithm corrects symptom information and ranks the reliability of node failure. Second, system model. The network slicing environment includes the underlying network topology and the virtual network topology. In order to construct fault propagation model. We use Bayes network knowledge construct the fault propagation model. The model includes two parts: the top node present symptom and the lower node present fault. The steps of optimization method for the probability of positive symptoms adopted in this paper include three sub-processes. First, calculating the alternative probability of each node. Use this formula. Second, sorting according to the alternative probability. And lastly, symptom optimization. The failure model can be optimized based on the importance of the node and the number of the negative symptoms of related services. The formula 12, use this 12, can be used to calculate the fault credibility of network node. Third, algorithm. The fault diagnosis algorithm based on service characteristics on the software-defined network slicing proposed in this paper includes three processes. First, building an initial fault propagation model. The underlying network services provider first receives a collection of abnormal services from the virtual network. Then, they can build a fault propagation model of the underlying network and abnormal services based on the mapping relationship and the virtual network resources occupied by the abnormal services. Second, optimizing the fault propagation model. The positive symptom values in the fault propagation model are first optimized, and then the fault credibility of the network nodes is calculated and arranged in descending order. Lastly, the fault set diagnosis. We can use the sorted fault credibility set to construct a suspected fault propagation model. Determine the fault set based on the maximum coverage algorithm. When constructing fault set, we can assume that the number of simultaneous faults is k. Therefore, a set of k suspected faults consisting of 1 to k fault nodes is constructed at the same time. When selecting fault node based on maximum coverage, we can use this formula to calculate. Fourth, simulation results. The network topology in the experiment environment is generated using GTITM tool. The generated network topology includes two parts. One, virtual network, and two, underlying network. The network nodes of the virtual network obey the uniform distribution of 5 to 5th. The network nodes of the underlying network increase from 100 to 500. The resource allocation from the virtual network to the underlying network uses the classic algorithm. In terms of network node failure simultaneity, the prior failure probability of the bottom node is set to obey the uniform distribution 1.001, 0.01. The state of the network node is updated once at an interval of 20 seconds to simulate the dynamic characteristics of the underlying network. In terms of algorithm comparison, compare the FDAOSC algorithm in this paper with the fault diagnosis algorithm based on resource-bearing relationship. First, the comparison of accuracy rate is shown in this figure. From the figure, it can be seen that the network size has a small effect on the diagnosis accuracy of two algorithms, and the accuracy of the algorithm in this paper is higher. It shows that this paper optimizes the symptom site and the fault site, thereby improving the accuracy of the fault diagnosis model. Second, the comparison of fault alarm rate is shown in this figure. It can be seen from the figure that the two algorithms have achieved relatively stable diagnosis results on the different network scales. The fault alarm rate of alarm is lower than that of the traditional algorithm. This is because the algorithm in this paper evaluates characteristics such as symptom status and fault credibility, and better solves the problem of inaccurate fault propagation model caused by dynamic environment. The algorithm in this paper improves the accuracy of the fault diagnosis model data, thereby reducing the fault algorithm rate. Lastly, the comparison of time is shown in this figure. It can be seen from the figure that as the network size increases, the diagnosis time of the two algorithms increases fast. Compared with the existing algorithm, the diagnosis time of the algorithm in this paper has increased slightly. This shows that the algorithm in this paper optimizes faults and symbol terms, and there is a certain time overhead. However, the algorithm in this paper constructs a set of suspected faults based on fault credibility. At the time to infer the fault is short. Lastly, the conclusion and the future work. The software-defined network slicing technology makes the relationship between faults and symbol terms in the fault diagnosis algorithm more complicated, resulting in a decrease in the accuracy of the fault diagnosis model and the performance of the fault diagnosis algorithm. To solve this problem, this paper proposes a fault diagnosis algorithm based on services characteristics on the software-defined network slicing. When evaluating the importance of nodes, this article only considers the centrality of nodes and the number of links. The next step is to enrich this content and analyze the node attributes, such as approximate ideal ranks method and the analytic hierarchy processes to better improve the algorithm performance. This concludes my presentation. Thank you.
Hello everyone, my name is Liu Zhengyuan. My primary affiliation is Beijing University of Post and Telecommunications. I'm going to explain the paper Security Situation Awareness and Interference Control Method for Power Wireless Private Networks based on Dynamic Baseline. Firstly, I will introduce the background, and I divided this part into two parts. The structure of communications, interference, and interference control in this paper is shown in the figure. System internal interference is aiming at the internal interference of the system. The method of interference, coordination, and power control are usually used to achieve the purpose of network interference control. Aiming at the external interference of the system, the relevant data of the system are collected and analyzed firstly. Then the interference source is determined and the network interference is controlled on the basis of determining the interference source. Secondly, the flow chart of the algorithm is shown in the figure, which is mainly divided into three steps: detection, analysis, and adjustment, and corresponding to equation 1, 2, 3. The equation 1 is to calculate the SINR value of the JS user served by the ICE base station. The equation 2 indicated the proportion of SINR values of all terminals connected to the ICE base station lower than the minimal threshold, and the interference degree of the base station is judged by the proportion. The baseline value is an adjustment by this equation 3. Then enter the next stage for interference control and enter the monitoring stage. Thirdly, I will introduce the simulation and the result analysis. In the simulation scenario, the network topology setting is 1,000 meters times 1,000 meters, including 19 macro base stations with 57 cells and 80 terminals, which are randomly deployed in the network. Network specific parameter setting is as follows. The maximum base station power is set at 500 W. Bandwidth is set at 180 kHz. Speed requirement is 0.5 to 1.5 MB per second. Internal gain is 10 dBi. The minimum value of baseline Y is initialized to negative 10 dB. Noise of different intensity is applied as shown in Figure A. 3 groups of experiments are set up respectively, corresponding to 3 kinds of noisy environments, namely high, medium, and low noise respectively. The noise value changes with time, and the random disturbance is added at the same time. By visualizing the simulation analysis results, the SINR interval distribution obtained by different signal terminals is shown in Figure B. We can see that base station numbers 30 and 80 are affected by interference. The simulation experiments are carried out in the environment of low, medium, and high interference, which are divided into 3 groups. Each group of experiments includes the interference controlled group and the interference not controlled group. I will show the experimental results in a low interference scenario. The under control group, as shown in Figure A. In the low interference scenario, the SINR value of the base station measured from different distances are simulated. When the interference control algorithm is used, the SINR value of each base station decreases slightly and the SINR value slowly returns to the original level after the interference ends. The no control group are shown in Figure B. In the low interference scenario, the SIR values of the base station are also measured from different distance. When the interference control algorithm is not used, the SINR values of each base station decreases sharply. Then I will show the experimental results in a median interference scenario. The under control group are shown in Figure A. Thinner SINR value of base station also measured from different distance and simulated in the case of moderate interference. When the interference control and algorithm is used, the SINR value of each base station decreases more than that in the case of low interference. The no control group, as shown in Figure B, SINR value of base station are also measured from different distances under moderate interference. When the interference control algorithm is not used, the SINR value of each base station drops sharply and is obviously lower than that of the control algorithm. Finally, I will show the experimental result in a strong interference and scenario. The under control group are shown in Figure A. In the case of strong interference, the SINR value of the base station is measured from different distances when the interference control algorithm is used. The SINR value of each base station decreases slightly compared with low interference and medium interference and is within the acceptable range. The no control group, as shown in Figure B, SINR of base station is still measured from different distances under strong interference. When the interference control algorithm is not used, the SINR value of each base station drops sharply and the network state is very poor. This is the end of my sharing. Cheng, thank you for watching.
Hello everyone, my name is Liao Boxian. It's my great honor to be here that I can represent my team to give a presentation about our recent work. And the title is Energy-Aware Blockchain Resource Allocation Algorithm with Deep Reinforcement Learning for Trusted Authentication. This work is done by Li Fangao, Xiaotao Zhang, Qingfang Liu, Huifeng Yang, Jing Guo, and me. Now, let's start our topic. My presentation will be divided into 4 parts. First of all, I will introduce the background of this paper, the existing problems, and the main contributions of our work. Next, I will introduce our proposed algorithm. In addition,
I will describe the simulation results, and at last, I will make a conclusion. So, let's begin with the introduction part. Nowadays, Internet of Things is playing an important role in improving the quality of urban life, involving manufacturing, transportation, construction, mining, and energy. And the traditional processing method for data is to transfer the data to the centralized cloud. However, lots of IoT services need real-time computing, such as safety assistance driving and autonomous driving. Therefore, the Cloud Edge Terminal Cooperative computation offloading schemes have attracted more and more attention and have already been effectively applied in various IoT schemes with the help of other techniques like deep learning and reinforcement learning. Blockchain is a kind of technology that can maintain a set of authorizable ledger records among participants who do not trust each other or have weak trust without intermediate participation. Is a new application mode of computing technology, such as distributed data storage, point-to-point transmission, conscious mechanism, encryption algorithm, which is essentially a decentralized database. Since the blockchain is almost tamper-proof, it can conduct security transactions and data processing without authoritative intermediaries. Blockchain has the characteristic of safety, transportation, interactivity, and decentralization, and is currently applied in various fields such as finance, manufacturing, healthcare, etc. In order to realize the trusted authentication of power terminal and reduce the security risks of terminal access, we use the security and tamper resistance of blockchain and used mobile intelligent terminal as the key carrier of identity authentication and electronic signature. The coin data is placed on the blockchain. The blockchain is used to realize the safe storage of authentication information, and the smart contract is to use to realize the safe and autonomous execution of the authentication process. With the rapid development of the IoT, the power terminals of the IoT are diversified, and the most powerful terminals are more vulnerable to attacks due to their low security. The traditional terminal authentication mechanism face many problems. The isolated data island of each unit cannot communicate. The risk of data leakage of decentralized management system is high, and the data authentication format and the security level are different. The centralized authentication solution is not suitable for the authentication and access of highly distributed IoT devices. The non-tamperability of blockchain can well guarantee the trust of the system. However, the application of blockchain technology is limited by the mining process. That is, miners are required to complete computing-intensive tasks, which puts forward extremely high requirements for the computing capability of the terminals. Therefore, we use mobile edge computing technology to solve these challenges. MEC service has powerful computing resources, and compared with the cloud computing mode, the distributed structure of MEC system makes computing resources and storage resources closer to mobile device. It can offload the computing tasks of mobile devices to the edge server nodes for computing. In order to improve the calculation rate of the system. In order to solve these problems, we have carried out the following contributions. First of all, we establish a blockchain-based H-terminal cooperative resource allocation architecture, which is composed of MEC system and blockchain system to ensure the trust of terminal authentication information. Next, we propose the energy-aware blockchain resource allocation algorithm with deep reinforcement learning to optimize the total energy consumption of the system. In addition, we simulate different parameter settings. The proposed algorithm has faster coverage space and better performance. Then, I will show the proposed mechanism in details. As shown in this picture, the blockchain system is located at the edge layer, and we store the trusted authentication information of the terminals in the block. The MEC server is located in the edge layer, and the edge node can be connected with the base station. In this system, we suppose that each mobile terminal can perform the mining task of the blockchain as a miner, and can access its nearest edge node for cooperative task offloading. In order to realize the reasonable resource allocation of the system, we propose a joint optimization problem to minimize the total energy consumption of the system, and optimize the offloading decision and the transmission power allocation decision. We express the joint optimization problem as follows. As we can see, constraint C1 ensures that the total time for the system to complete the mining task does not exceed the completion time. Constraint C2 means that the sum of transmission power does not exceed the total power. Constraint C3 ensures that all CPU frequencies are non-negative and finite. Constraint C4 ensures that the task offloading decision is effective. We model the optimization problem as a Markov decision process to obtain the optimal resource allocation strategy. Due to the dynamic characteristics of the system, we proposed an algorithm based on deep reinforcement learning, a synchronized advantage actor critic, to solve the problem. The A3C algorithm is to create multiple parallel environments on a machine, put actor and critic in multiple different threads for training and assign tasks, and update the parameters of local network to the global network. Each single thread completes the learning and acquire the comprehensive learning of updated parameters from the global network regularly. Each thread will learn from the environment identity and explore different strategies in parallel. Therefore, we use A3C to explore the optimal offloading decision of H-terminal cooperation. And the Markov decision process includes states, action, reward, and so on. We let the states be S, and we express the state space as the current time as the combination of the channel condition and available computation resource of the MEC server. We let action be A, the action space including offloading decision and transmission powerful allocation decision. Next, for each stage in the process of finding the best states, the agent performs a possible action in the state and will get a reward. So the reward of deep reinforcement learning can be expressed as R. In order to evaluate the performance of the EABRA algorithm under different parameters, We use TensorFlow 2, based on Python 3.7 for simulation, and establish a model composed of MEC and blockchain system, in which the network coverage radius is about 500 meters. We can use TensorBow, the built-in model of TensorFlow, to see the visualization of A3C algorithm architecture. As shown in the figure 2, we can see that the A3C architecture consists of a global network and 8 work agents. The A3C algorithm starts from building a global network, and the parameters in the global network will be synchronized to each work agent. Figure 3 shows the internal structure of a work agent. Each work agent has actual network and a critic network, and can interact with the surrounding environment. After the interaction, work agent will update the global network parameters according to their own network parameters. In order to verify the effectiveness and feasibility of the EABRA algorithm, we compare it with the random, which mobile terminals perform action randomly. As shown in the figure 4, we compare the loss function of the two algorithms, and we can see that the EABRA algorithm coverage faster, and the performance of the random is poor, which can hurt the coverage. As we can see, Figure 5 shows the impact of the computing capacity of each node on the total energy consumption of the system. It can be seen that for all things, the total energy consumption of the system increased with the increase of the edge node's computing capacity. It is because the CPU frequency of the edge node increase. Although the calculation rate will increase, the communication overhead will also increase, which will lead to an additional energy consumption, therefore increasing the total energy consumption of the system. And the figure 6 shows the effect of the transmission power on the average reward. It can be seen that the performance of the EABRA is always the best. It is because we jointly optimize the task offloading decision and the transmission power allocation decision, and find the optimal resource allocation scheme through the DRL algorithm. At last, we can draw the following conclusion. First of all, we propose a blockchain-based H-terminal cooperative resource allocation architecture, including MEC system and blockchain system. Local mobile terminal computing mode and H-node cooperative computing mode are used to process the mining task of the blockchain system, so as to ensure the trust of the terminal authentication information. Besides, in order to optimize the total energy consumption of the system, we model the problem as a MDP problem. Jointly optimize the offloading decision and the power allocation decision, and propose the EABRA algorithm with deep reinforcement learning for solution. In addition, the simulation results clearly show the superiority of the EABRA algorithm. Under different parameter settings, the EABRA algorithms has faster coverage speeds and better performance. That's all of my presentation. Thanks for listening.
Hello everyone. I'm very glad to have this opportunity to attend the conference. The topic I am asked to speak on is IPv6 header compression scheme for Power Internet of Things. My presentation will include these three parts. First, the background. Second, the main content in the paper, including compression scheme and results. And the last, some conclusions we have got. Firstly, I would like to introduce the background of research. Under the demand of Internet of Everything, the demand for network addresses has increased, and the IPv6 protocol has adhered in an excellent opportunity for development and application. The left figure presents the location of the 6LoWPAN adaptation layer in the network protocol layer and the efficient conversion between IPv6 packets and IEEE 802.15.4 frames. The right figure illustrates the IPv6 packet header. The maximum transmission unit MTU length is 1218 bytes, and MTU is 127 bytes, which does not meet IPv6 requirements. Therefore, when the packet transmitted through IPv6 is greater than its MTU, it must be fragmented and reorganized using 6LoWPAN. If it is directly transmitted without compression, the transmission efficiency obtained is low. Therefore, header compression is required to improve the data transmission efficiency. The second part, I'd like to talk about the main contents. We can see the for compression scheme, LoWPAN HC1, a header compression scheme suitable for local link networks. LoWPAN HC1 Energy use UDP as default transport layer protocol and to compress it. LoWPAN IPHC. The LoWPAN IPHC adaptation layer header is a global shared contact table. Some frequently occurring IPv6 addresses prefixes can be saved. LoWPAN IPHC Energy. In the energy metering system compression scheme, the checksum field setting is deleted. By default, checksum is used to check the system and the HLIM is further compressed. The four compression schemes are introduced below respectively. The three figures shows LoWPAN HC1 of HC1 encoding and the overall encoding format of specific fields. We can see the first two figures present the overall coding format of LoWPAN HC1 and specific fields of HC1 coding, respectively. This scheme sets the specific compression format of the data packet. to the 1 byte LoopHC1 compression control header field. The latter figure illustrates the encoding field. An HC2 encoding type field indicates whether an H is comprised. When HC2 encoding field is 0, no compression is performed. The HC2 encoding field of 1 indicates that UDP is comprised. In the HC1 encoding field of LoopHC1, the type of the adjacent joined part is set through the net header type field, and UDP compression is set through the HC2 encoding type. In energy management systems, we recommend to use UDP as default transport layer protocol and to compress it. First figure presents the encoding format used by the protocol. The second presents the encoding format of the HCE field. The first file bits are similar to the HC1 encoding field, which is used to set the IPv6 source or destination address, transmission type, and stream label compression. Because UDP is used as the default transport layer protocol, the setting of the last 3 digits of LoopHC1 for the protocol type can be replaced by compression setting for the UDP header, and the compressed header length can be reduced by 8 bits. LoopHC sets the parameters of IPv6 header compression through the LoopHC field, and the figure represents the specific contents of the field. As a new header compression scheme, IPHC overcomes shortcomings such as LoopHC1 can effectively compress only local network data packets and can more effectively compress various communication scenarios. LoopHC sets the parameters of IPv6 header compression through the LoopHC field. We modified the compression scheme LoopHC according to the characteristics of the default UDP protocol adopted by the energy management system, and the header compression scheme through the first picture can be achieved. The second presents the specific coding field of LoopHC energy. Adaptive compression scheme HC energy can further improve the compression efficiency by integrating 2 compression schemes. The figure presents the data message format of LoopHC energy. The first 3 digits 1 are used as the category identifier of the data packet, and the first digit category control is used to select the type of the compression scheme to be used. When set to 0, the LoWPAN HC1 energy compression scheme is used. Otherwise, the LoWPAN IPHC energy compression scheme is used. The two figures present the meaning of specific fields. When the type control field is 0, LoWPAN HC1 energy is used for compression. The compression scheme uses the same coding format as the HCE field does in LoWPAN HC1 energy, and fallbacks are added beforehand as reserved bits to obtain the 12-bit LoWPAN X energy field to set compression parameters. When the type control field is 1, LoWPAN IPHC energy is used for compression. The HLIM field is omitted, and the maximum hop limit field is not compressed. Other fields remain reserved, and the 12-bit LoWPAN X energy field completes the control of the compression parameters. A compression radio was used as a compression scheme index, like the size of the data packet before and after compression B, I, and C respectively. The compression radio P can be calculated using the following regular equation. Under various compression schemes with different probabilities, the observed data packet was the compression effect of the local link. The following table presents the results and the specific data results. Compared with LoWPAN HC1, the compression rate of LoWPAN HC1 energy increased by approximately 1.90%. Compared with LoWPAN IPHC, the compression rate of LoWPAN IPHC energy increased by approximately 1.88%. Now we come to latter part, conclusion. The IPv6 protocol is required by the IoT system for network scalability. To improve the data transmission efficiency, IPv6 data header compression is necessary. Through the default transport layer protocol UDP, the compression efficiency can be improved. LoWPAN HC energy can use an adaptive method to compress the data header to improve the compression effect of the data packet. That's all. Thank you. Hello everyone. I'm very glad to have this opportunity to attend the conference. The topic I am asked to speak on is IPv6 Outage configuration method in 6 LoWPAN oriented to the Internet of Power Things. I'd like to divide my presentation into 3 parts: background, contents, and conclusion. Firstly, I would like to introduce the background of research. The IPv6 protocol has emerged to meet the increasingly diverse needs due to the characteristics of broadband and low power consumption. The use of IPv6 protocol is hindered. The function of 6LoWPAN has become a critical key technology for the IP-based Internet to be able to communicate with each other normally. The legality of the IP address needs to be unique. The design idea of addressing by location information has significant promotion and application prospects and needs further development. IP addressing combines the prefix of the underlying wireless personal area network with the link layer address of the interface to generate an IPv6 address. The length of the address is 128 bits, which are the routing prefix and the interface identifier. The nodes of the same 6LoWPAN network share the prefix of the route, which can be obtained by the broadcast message of the link. The 16-bit short address is generated according to the 64-bit interface identifier. Taking the location information as the focus, we analyze the accurate algorithm of the location-based 6LoWPAN network to automatically configure the address. Establish a LAN network architecture based on location information. Based on the location information of nodes, achieve the purpose of rapid clustering. Each grid is independent of each other and can configure the address effectively at the same time, so that the delay of the network can be reduced. Next, the second part, I would like to introduce the contents of this paper. Firstly, we can see the location-based information network architecture. In the Power Internet of Things, the location information between nodes can express the distance and the directionality of needs in the physical space. And the nodes themselves have natural similarities and differences. This paper applies the distance, direction, and similarities and the differences of node location information, and on the basis of 6LoWPAN network characteristics and technical research, we analyze the address configuration scheme based on location information. The figure is a network topology diagram based on location information. We cite the coordinate of the edge route, and each grid is identified by the coordinate xy. The node is connected to the network. A specific positioning method is firstly used to obtain its own positioning coordinates of x and y. And the following formula is performed to calculate the corresponding selected grid coordinates. These two formulas. As shown in the figure, the IPv6 address structure of the network architecture design. It is a network architecture based on location information. Its purpose is to complete the function of converting location information to address space, so that the location information of the node is included in the node's corresponding IPv6 address, which provides great convenience for the specific application of the 6-loop network based on location information. In addition, according to the natural similarities and the differences of node location information, the network achieves the function of rapid clustering without other address configuration and complicated clustering algorithms. Moreover, under the condition of a large-scale network and a large number of nodes, a very large network can be divided into multiple subnets, and all subnets are independent of each other, and address configuration can be completed simultaneously, which greatly reduces network delay and expenses. In the case of different states, the functions undertaken by the nodes also have certain differences. This program mainly involves 4 types of nodes: newborn node, normal node, proximate node, and head node. When the new node approaches the network, it can obtain the corresponding grid ID. First, it will send out an address application to neighboring nodes within one hop of the surrounding area, and the present node will respond after receiving the request. If the neighboring nodes in the surrounding one-hop interval are all new nodes or normal nodes, that is, there is no free address, the scope will be extended and the address application will continue. If the proximate node allocates the corresponding address to the new node with only one redundant address, then after a redundant address is allocated to the new node, the node becomes a normal node because it no longer has a spare address. The proximate node itself has a redundant address. After configuring all the redundant addresses and the process of configuring other addresses, it will become a normal node. In the same way, when a normal node obtains other spare addresses in the network, it can also become a proximate node. If normal nodes and the process nodes are separated from the network for various reasons. They become invalid nodes. The schematic diagram of nodes these changes is shown in this figure. Next, address allocation method. IP address allocation. After a new node joins the network, it needs to extract the horizontal and vertical coordinates of the deleted grid according to its own positioning information, and set a hide node in each area. We set the ID of the hide node to be 1. The hide node covers the entire address space. When configuring this address, the configuration should be started from the hide node, and following links, a new network node is added to obtain the internal ID process. In the early stage, when it does not get a unique address, the node uses its own MAC address as a temporary address when communicating. Address recycling. The nodes of the 6-loop network will use batteries for energy supply, because the battery has a certain storage capacity and is affected by environmental factors, such as floating wireless signals. The network nodes are often connected for different reasons. Therefore, before the node is disconnected, its address must be recovered. In a dynamic network, the head nodes, normal nodes, and process nodes will send edge or leave packets to notify neighbor nodes within one hop before leaving the network. The neighbor node that receives the edge leave data package will immediately send back the edge hello data package to the leaving node. The disconnected node will theoretically receive the reply information from all neighbor nodes and send the edge OK data package to the first replying node. The data package contains its own address information, and the nearest node will be notified through the data package. The experiment uses Outage, a modular as the simulation platform, to simulate and analyze, and compare it with the DAAM address configuration scheme, mainly based on the aspects of the average overhead of address configuration and the success rate of address configuration. The network is divided into 8 network grids, that is, the ordinate and the obscure of the node occupy 2 bits respectively. The value of the number of nodes n is 40, 50, 60, 70, and 80. From the 3 figure, we can see, compared with NPAAP, The binary tree address configuration scheme proposed in this paper is mainly unicast override and multicast override. First, the network is divided into network grids based on location information to achieve clustering. Therefore, address configuration is performed in each grid, and there is almost no network-wide broadcast override. The new node only sends multicast packets to neighboring nodes within one hop when it joins the network and when the node leaves the network. If there is no free address with one hop, the node will expand the range of sending address requests. Therefore, only a limited number of multicast data packets are generated. At the same time, the range of multicast packets is limited to each grid. Although the number of multicast packets is large, the overhead of each multicast data package is smaller than NP-APP. In addition, new nodes choose processing nodes for themselves, which are generally close to them, so unicast overhead is also reduced compared with NP-AAP. We come to last part, conclusion. The processing node will automatically obtain the corresponding address space based on the number of nearby IP address nodes that have not been allocated. This method reduces the probability of address configuration failure. The performance comparison with the traditional address configuration mechanism proves the feasibility of the configuration mechanism. That's all. Thank you.
Hello everyone, my name is Yang. I'm from Beijing University of Post and Telecommunications. It's my honor to be here to show our work to you. I'll briefly talk about our work about a resource consumption attack identification method based on data fusion. My speech will be divided into 5 parts. I'll briefly summarize the motivation of our work. To tackle with the existing problems, we propose a novel approach using data fusion, and I'll present my idea of that. At the end of the paper, the simulation results are presented, so you can see the details of results on the slides. Now we move on to discuss the motivation of our idea. Network attacks can be divided into 2 categories. The first one using the information system security vulnerabilities to bypass information system security protection measures and enter information systems to achieve the purpose of controlling all the information systems. Such attacks are generally called counterattacks. The another one is very different. Although such a network attack cannot control the information system, the information system's service capability is downgraded, or the service capability is completely lost due to the large consumption of information system resources, such as memory resources, CPU, the computing resources, bandwidth resources, and like. However, in this paper, we focus on network resource consumption attacks, which generally refer to hackers using reasonable service requests to occupy extensive system resources, so that other normal users cannot get enough resources. It's a very serious thing since the system stops responding to normal service requests. It cannot run in a normal way. That is to say, when a hacker generates an extensive number of network server requests, a large amount of resources of the terminal server are abused. The normal users cannot use the servers. The resource consumption attack is mainly to exhaust a certain network resource. In the attack process, the terminal server attacks the terminal server and the server's CPU, memory, communication link, or other resources. They are overloaded. The traditional means of network resource communication attack countermeasures are intrusion detection and intrusion response. For example, detection method based on anomaly detection can be used for detecting network resource consumption attack attacks. Besides, resource consumption attacks are always accompanied by anomalies in the system attributes of each node, and attributes changes of each node has potential connections. In this paper, we aim to find these potential connections to detect the resource consumption attacks. However, we only can detect attacks until very large amount of data is accumulated on the victim side. The defense is passive. To deal with that problem, we are supposed to identify the attacks at a very early stage. Therefore, we introduce the data fusion, a multi-level and multifaceted processing process, which involves detecting, correlating, combining, and estimating data to analyze the correlation between nodes in the network to achieve early detection and identification of resource consumption attacks. Now I'll bring you the overview of the algorithm. According to the resource consumption attacks that may exist in the network, the correlation matrix between the nodes is built according to the correlation analysis. The nodes that are under attack are picked out. After integrating all node information, we convert node data into evidence in the DS evidence theory. Finally, using the DS evidence theory, each evidence is distributed according to the basic probability of the node, so as to effectively identify the resource consuming attack. I would like to give the details. First, the correlation between any pair of nodes is calculated using the maximum information coefficient, thereby constructing a node correlation matrix. The corresponding attributes of the node pair Si and Sj are granted as the random variables x and y. The correlation of nodes Si and Sj can be calculated as follows. Second, we calculated similarity. The nodes above the average will be marked as the normal nodes, and other nodes below the average are marked as possible abnormal nodes. Using the normal nodes, we generated the evidence. For every attribute associated with each resource consumption attack tab in the set, the evidence generated by each node is calculated for the mass function generated by different attack tabs. To improve the fusion precision, the weight of evidence is recalculated. Finally, the BPA of the revised evidence is like that. this time, the DS evidence theory is applied to merge each evidence according to the basic probability of nodes. Thus effectively identify network resource consumption attacks. First, BPA evaluates the source of evidence according to the basic probability and calculates the trust function and likelihood function of each proposition. Secondly, an interval indicating the strength of support for any one proposition is calculated as the trust function and likelihood function are regarded as the lower bound and upper bound of this interval. Finally, using the DS evidence theory, the individual evidence is distributed according to the basic probability of the node. By sorting the results of the aggregation, the recognition result of resource consumption attack is obtained. We performed experiments on iris dataset at first. We calculated the BPA of each hypothesis for the existing four evidences. It can be seen that all the evidence supports the proportion S is relatively large, so the fusion results should support proposition S. On this page, you can see the comparison between the classic DS improved algorithm and the recent improved algorithm, also including the proposed algorithm fusion result. All algorithms has the highest support for proposition S. Also, you can see among them, the support of the proposition S is significantly higher than the proposition E and the proposition V. Moreover, the support of algorithm for correct proposition S is very higher than of other three algorithms, so it can be identified more easier than other algorithms. Considering the accuracy, our algorithm also performs very well. When there's no abnormal evidence, the accuracy of our algorithm is the highest. You can see at these two figures. The accuracy of the four algorithms gradually decreases as the proportion of abnormal evidence increases. However, our algorithm has the slowest decay rate. So we can conclude that our algorithm can better deal with the abnormal evidence and obtain higher recognition accuracy. Now, to summarize, a resource consumption attack identification method based on node multi-dimensional data fusion is proposed. We use correlation. The normal nodes and the possible abnormal nodes are divided, and each node is assigned different weights. That's converting the nodes into evidence in DS evidence theory. Then, according to the basic probability distribution function of the node to the attack tab, the DS evidence theory is used for fusion, and the resource consumption tab attack is effectively identified. So thanks for listening.
Dear colleagues and friends, good afternoon. In this extraordinary year, COVID-19 epidemic has brought great inconvenience to our scientific research and life. Fortunately, we are working together to make our conference a success. Once again, I would like to thank all authors, TBC members, and TBC chairs for your hard work. Special thanks to the conference manager, Natasha Onifra. Without your support, SmartGIFT 2020 will not work successfully. After review and recommendation by the organization committees, I declared the best paper is a resource consumption attack identification method based on data fusion by 李斌甲、永华霍、林宁葛 Zhongdig Yang from Science and Technology and Communication Networks Laboratory, Agriculture Bank of China, the University of Post and Telecommunications. Congratulations to the authors and affiliations. We hope you can still submit the paper to SmartGIFT next year. Thus, there are many regrets in this year's conference. If I can, I hope to continue to serve the conference next year and will try to organize special issues for attract more people to this conference. Hope to construct an attractive platform for researchers over the world in the field of smart grid. Look to see you next year. Thank you.